Alright, hello Year 10 and welcome to the first of 3 videos that are going to go through preparations of salts. And the first one is preparing an insoluble salt, which is your first hint that your product is going to be a solid. Okay? Insoluble, so it doesn't dissolve in water and won't be aqueous. The easiest way to make an insoluble salt is by precipitation reactions that you learned about in the previous lesson. So that tells you you're going to have 2 aqueous reactants. They're going to produce your precipitate and a second aqueous byproduct. The most common example that comes up on your exam and in classrooms is the preparation of lead iodide. And you would have seen this one before. This is the reaction where you take 2 colorless liquids, pour them together, and you get that really vibrant yellow solid that forms. That's lead iodide. So our formula PbI2, because the charge on lead is 2+, and the charge on iodide is 1-. Okay. So the easiest 2 solutions to make this from are going to be one with lead and one with iodide that are both soluble. So to get lead to dissolve, we often pair it with nitrate because all nitrates are soluble. So that would be PbNO3 And then the reaction containing iodide that's often used is potassium iodide. Because all group 1 salts are soluble. All right, so the lead and the iodide fall out as a precipitate, which leaves potassium ions and nitrate ions left over in solution, giving us our final product. KNO3 aqueous. All right, so to balance our equation, we have 2 iodides, so we need 2 iodides on the left, and same for the nitrates. Now we're good. Okay, so this is the reaction we want to do. But exam questions are not quite that simple. They usually ask you, how do you prepare a pure, dry sample of your salt? Okay. Keywords being pure and dry. So it's not going to be quite as easy as just mixing these 2 together, although that is step 1. So step 1 is simply taking a small beaker, okay, and adding your 2 solutions. So you add a bit of PbNO3, lead nitrate, and a bit of potassium iodide. Okay, you want to make sure you stir. So mix the solutions in a beaker. Mark schemes will sometimes say stir with a glass rod. That's just to make sure the reaction's complete. And you get your nice yellow solid PbI2 sitting on the bottom. Now what is left above the PbI2? Well, we know we have potassium nitrate, our side product. We're also going to have, of course, water, which is your solvent. And most cases in a precipitation reaction, you won't measure out the reactants perfectly ahead of time, so you might also have some excess reactants. So a little bit of leftover Ki or a little bit of leftover lead nitrate. Okay, so we've made our salt, but it's neither pure nor dry. So the second step is to separate that solid from liquid using your good old friend, the filter funnel. So funnel, filter paper, and a conical flask. Okay, your solid will get trapped in the filter paper, and the liquid will pass through the pores in the paper and collect in the conical flask. So you should end up with your KNO3 any excess reactants and water in the conical flask, and all your lovely PBI2 up here. Okay, but it's not quite that simple, unfortunately. This is still not dry and still not pure because all of this solution is still going to be stuck on here. If you think about when you filter, that's going to be a damp solid, and it's going to be damp with not only drops of water, but also little bits of the KNO3 and XX reactants that are dissolved in the water. So it's separated, but it's not pure. All right. So we filter to separate it. And we need other steps to purify. All right, so step 3 is to wash the residue, which brings me to a key word you should definitely be aware of back from the first topic of the year. When you do filtering, the solid in the funnel is called the residue, and the liquid that is filtered out is called the filtrate. So you want to be aware of those words again. All right, so our residue, which was very impure, we simply wash. You would get distilled water bottles and run a bunch of distilled water through it. This will flush out any little bits of KNO3 or excess reactants that were contaminating your solid and leave it nice and pure, though not dry. Okay, so we purified it, but it's still going to have water, so we need a fourth step. We need to dry it. So here we wash. And finally we dry. The drying step's really simple. You just leave it in a warm place. Okay, if we were in the lab, I would just tell you to put it on the lab bench. We'd put it by a window so the sun would come in, and you'd end up with your lovely pile of pure, dry PBI2 once all those water molecules evaporate. Okay, so there you have it. Preparation of an insoluble salt using precipitation reaction has 4 steps. First, you need to actually perform the reaction. Then separate the precipitate by filtration. Wash it with distilled water. And finally leave in a warm place to dry. And that's it.